How do bats navigate and hunt in absolute, impenetrable darkness?
Their secret isn't sight. It's a sensory marvel beyond human comprehension.
Echolocation, or biosonar, is their extraordinary ability to see with sound. They emit high-frequency sound waves, then listen for the echoes returning from objects.
These echoes create a detailed acoustic map of their environment. Bats don't just make noise. They sculpt their sound emissions precisely.
Their ears are incredibly sophisticated, designed to process these minute echoes.
From the timing and intensity of echoes, a bat perceives distance, size, and texture.
This allows them to navigate complex landscapes with astonishing accuracy, even in total darkness.
Echolocation isn't the single technique. It's a diverse array of specialized strategies.
Microbats, like pipistrelles, use high-frequency, short-wavelength sounds for fine detail.
Horseshoe bats use their unique nose leaf to focus sound beams, like an acoustic megaphone.
Some bats use constant frequency calls, others frequency-modulated sweeps, each for different purposes.
This incredible diversity in calls and ear structures reflects their diverse ecological niches.
Each bat species has uniquely adapted ears, perfectly tuned for specific frequencies.
These sophisticated structures are crucial for receiving and interpreting echoes.
Echolocation works by emitting high-frequency sound waves and listening for the returning echoes.
The time delay and direction of these echoes create a detailed sonic map.
Different bat species utilize a vast spectrum of frequencies, some even audible to humans.
Bats, like the horseshoe bat, use intricate nose leaves to shape and direct their sonar beams.
This allows for highly focused, narrow beam echolocation, perfect for hunting in dense environments.
Other bats emit calls directly from their mouths, often wide open during flight.
They rapidly adjust their vocalizations, adapting to changing distances and target movements.
Bats are master hunters, navigating solely by sound to capture prey with incredible precision.
By analyzing these complex flight paths, we can clearly see how the bats utilize echolocation to precisely track.
During the search phase, bats emit long, low-frequency calls to scan large areas.
Upon detecting prey, calls become shorter, more frequent, and higher pitched, narrowing the search.
The final, rapid terminal buzz provides minute-by-minute updates for pinpointing the exact prey location.
This intricate three-phase sonar system ensures an almost guaranteed capture of their flying meals.
Some bats, like the fishing bats, have evolved echolocation to detect ripples made by fish.
They use incredibly sensitive echolocation to discern the smallest disturbance on the water's surface.
Other bats are gleaners, listening for the faint sounds of prey moving on foliage or the ground.
Their highly sensitive hearing allows them to detect even silent, non-echolocating insects.
Vampire bats employ a muted echolocation alongside other senses for stealthy landings on large mammals.
Their echolocation aids in navigation, but thermal sensing guides the final, precise approach for feeding.
Echolocation allows these mammals to perceive their surroundings in stunning detail, even in absolute darkness.
They create a dynamic, three-dimensional sonic map of their surroundings, updating it milliseconds.
Each echo provides information about distance, size,
texture, and even the movement of objects. Bat colonies, often numbering millions, use echolocation to coordinate their mass exits from caves.
Despite the overwhelming numbers, mid-air collisions are remarkably rare thanks to their sonar.
In their roosts, bats communicate using a variety of social calls, distinct from echolocation.
Mother bats recognize their pups' unique vocal signatures, among thousands of others.
This vocal recognition is vital for the survival and care of young bats in dense colonies.
Beyond echolocation, bats have a complex repertoire of social calls for communication within their colonies.
As you can see, the higher frequencies suggest a new species, especially when cross-referenced with the wing beat patterns below. As you can see on the graph, this peak indicates a unique frequency in their echolocation signature.
The sound pulses out, hits an object, and bounces back. This echo provides the bat with a detailed map of the environment, even in total darkness.
Incredible. The echolocation patterns are completely different from what we hypothesized. They are adapting to the increased insect activity.
The biodiversity here is stunning. We've identified over 50 species of bats in this valley alone.
They use echolocation. They emit sound waves like this, which travel outwards. When the sound hits an object,